In this lesson, we will learn how to translate phrases, verbal phrases, into math sentences. So let's start working with some verbal phrases with addition. Anytime we see the words a number, we're going to let X represent that unknown number. So the first phrase we have is the sum of 8 and a number. Sum is a word that represents addition. And then we have 8 and a number. So you see how I just took some notes? So I'm going to add 8 and X together. Now addition is commutative, so we could also write it as X plus 8. Addition's commutative because 2 plus 3 is 5, and if I switch it, I still get 5. Right? So it doesn't matter the order that we add things. So letter B says a number increased by 15. So I've got a number, I'm going to let that be X. Increased by is for addition. And then I've got 15. So my expression is X plus 15. Now in letter C, we want to be a little careful. This says 5 more than a number. So I've got 5. I know that more than is for addition, and I've got a number, X. When you go to write an expression, it's good practice to start with your variable. So it's 5 more than the number, which means that the number comes first. And we end up with X plus 5. Now, we can also write 5 plus X, and it would be technically correct for this problem, but that's not the case when we get to subtraction. Let's work with some verbal phrases with multiplication. Again, we're going to let X equal the unknown number. Letter A says the product. So I know that that represents multiplication. Of a number, we're going to let that be X, and 5. Get used to when you see the words the product of, or the sum of, or the difference of, or the quotient of, to put the two things separated by the word and in parentheses. So we're going to multiply X and 5. This is perfectly acceptable for your expression. Although, common practice when we talk about multiplication is to put the number in front of the variable. Again, just like addition, multiplication is commutative. For example, if I did 5 times 3, I would get 15, which would be the same thing as if I multiplied 3 and 5 together. So it really doesn't matter the order that we multiply things. Letter B could technically be considered a multiplication or division problem, but the way it reads is a multiplication problem. So we have a third of, which is for multiplication, a number. Now a third is a fraction. 1/3 X. Okay. We could also write this as X over 3 if we wanted to. Okay. In letter C, we've got -3 times a number. So our expression is -3X. All right. Pause the video to try these 3 problems. Alright, so like I've already mentioned, subtraction and division are not commutative, which means that the order that we write our phrases does matter. 5 minus 3 is 2, but 3 minus 5 is -2. These two things do not equal each other. So the order that we write our phrase has an effect on the answer that we get. We're still going to let X equal the unknown number. So we have a number subtract 10. This one's pretty straightforward. Our expression is just x minus 10. Letter B is a little trickier. 10 subtracted from a number. So I've got 10. I know that subtracted from is subtraction, and a number is x. Let's start with our x. Are we taking x away from 10, or are we taking 10 away from x? And in this case, we're taking 10 away from x. So subtracted from requires us to switch the order of the two terms from what was written in the statement. Less than works the same way. We have 3 less than a number. So when we go to write our expression, start with x, and then less than means that we're going to take that 3 away from the x. Okay. Division is similar to subtraction. The order matters. 6 divided by 3 is 2. But if you divide 3 by 6, we get 1/2. 2 and 1/2 are not the same number. This may come as a surprise to some of you, but they are not the same. So we let x equal the unknown number. So we have a number, x, divided by 6. We don't use the division symbol very much in algebra. Get used to writing your division as the fraction bar. Letter B is the reciprocal, 6 divided by a number. So 6 over x. Okay. I'm going to write one more example on the side for you. 6 divided into x. 6 is the number that is going into x. So x is the one that is getting divided. So just be very careful when you go to write your phrases for division and subtraction. Pause the video and try the next 4 practice problems. All right, now we're going to get a little more complicated and work with some multi-step verbal phrases. X is our unknown number. So we have the word triple. Triple means 3 times. Then we have a number plus 5. So this expression is exactly as it's read, 3x plus 5. Next, we have a number, x, divided by 4 plus 3. X divided by 4 plus 3. This one is a repeat from earlier. We're just going to cross that one out. It's not even on your paper. Letter D. 5 times a number plus 11. 5x plus 11. Now letter E has the same pieces as D. We've got the 5, we've got times, we've got the number, and 11. But this says 5 times the sum of a number and 11. So this represents addition. That addition is going to go where the and sign is, which means that we have to add x plus 11 first and then multiply by 5. So the sum of is a set of parentheses words. Anything that comes after that gets grouped by parentheses. Pause the video to try the next 5 practice problems. All right, this one's for all the marbles. 3 times a number increased by 4 is subtracted from 2 times the same number. Whew, that's a mouthful. So let's start taking some notes. 3 times a number increased by 4 is subtracted from 2 times the same number. All right, so we have two pieces set up to be subtracted. 3x plus 4 and 2x. But which one comes first? Are we going to take 3x plus 4 away from 2x? Or are we going to take 2x away from 3x plus 4? The way that this reads, 3x plus 4 is subtracted from 2x. So we start with the 2x, and then we subtract, in parentheses, 3x plus 4. Try this one on your own. And this ends at the end of part 1. Once you've completed all the practice problems, please come and check in with me so that I can go over them with you.